I'll skip ahead. The next section of my presentation, I'm going to talk about the grain recovery system that we did with Global Fabrication. So just a quick introduction to Global Fabrication. So they're a manufacturer of agricultural products. They're based in kind of the heart of farm country in Hampton, Iowa, which is kind of centrally located in Iowa. They specialize in grain handling equipment. So they were gracious enough to allow me to talk about their application, but then also provide some pictures of just various different products that they manufacture. So, and kind of their specialty is, grain hoppers, towers, catwalks, conveyor systems, and then lastly, which is going to be kind of the focus of my presentation, is they also build custom machines. So I wanted to talk a little bit about the practices in the ag industry. Just to kind of set up the base for the machine that we're going to talk about. So if you're so in the Midwest, it used to be if you were to drive through, any small town in the Midwest, you would know that every town that had a granary on a rail, basically at harvest time, they would take that grain in at those granaries and ship it out. Well, those granaries are becoming kind of far and fewer between. And so that grain is now happened to be brought into more larger or centralized locations. So before it can be trucked out or put out on rail. So with that, so in the past, that grain was either stored in a silo or in a granary, until it was ready to be shipped out. Well, that's become, extremely expensive to, have to build those bins and that storage for only a short period of time. So the kind of the practices have changed, where now they've started to pile that grain on a concrete slab, and then cover it until it's ready to be, transported out. So the piece of equipment that I'm showing over on the right-hand side of the screen, what this is a drive-over belly dump conveyor system. And that's really one of the main pieces of equipment that's used to make these large piles. So what would happen is that, when a farmer brings in his harvest, he would drive over this conveyor system. His belly dump trailer would dump that grain on the conveyor system, and you'd make this enormous pile of corn. So once you have this enormous pile of corn, you have to be able to do something with it. And that's really what fueled the need for this grain recovery system. So what you're seeing here is essentially a self-propelled mobile conveyor system that was designed specifically for picking up those large piles of corn and filling up semi-trailers so they could be transported to other locations to be shipped out. So this particular system is capable of moving 40,000 bushels of grain per hour. And to put that in perspective, this machine, it can fill an entire semi-trailer full of grain in less than 2 minutes. It's set up in such a fashion that they'll pull semi-trailers up on either side of the machine. So as one trailer is being filled, the other one is staging, and vice versa. And it's a continuous operation. So the other method for moving these giant grain piles is really using giant wheel loaders, which is not a continuous process. It takes a lot of repetitive action of scooping up a load of grain and filling these trailers. So this machine is intended to be a much more efficient and faster method for moving that grain and picking it up and getting it off to where it needs to go. So just a couple of high points about this machine. It has two large 24-inch augers, and I'll give you a better look at that on some of the slides to come. But those augers, really, they're used to auger that grain into the center conveyor. And then that center conveyor is a 54-inch wide high flight conveyor that brings the material up to the top. This system is powered by a 600 horsepower Cummins diesel engine. And then this system, because they need the ability to move this cab and maneuver it, is it is a full electro-hydraulic control. So pretty much everything that we're going to talk about on this system, whether it be the steering, the hydrostats, the work sections, they're all steer-by-wire type of functions or control-by-wire functions. And then last, being from the fluid power industry, I figured I'd add this point, is that this particular system, it has 6 pumps, including the hydrostat, and it's capable of producing up to 325 gallons per minute. So pretty impressive machine. Just quickly here, I'm going to go through the operator interface. So what you see in the picture here is the main interface that the operator would use. Up in the top right-hand portion of the screen here is a large 12-inch touch screen or color touch screen display from Cross Controls. To control the primary functions on the machine, we have 2 CAN-based joysticks, and then we also have a CAN-based throttle control. And then it's kind of you can't really see it real well, but there is also a CAN-based keypad here for controlling some of the other functions on the machine. The machine is controlled by 2 primary controllers. We decided with the customer's help that these controllers should be located kind of central to where the I/O is. So that's why we broke these into two control units. There's hydraulics up on the top of the conveyor that are being controlled for the conveyor and spout controls, and then there's hydraulics for the cab controls that I'll talk about in more detail. So that's being controlled by this controller, and then down on the chassis of the machine, we have the controller that's controlling the steering, propel, the cooling circuits, and then the hoist to lift the machine up and down. And I'll talk in more detail about some of these subsystems on future slides. One of the things I did want to point out is that we did make a decision to put this controller in an enclosure just to give it some added protection. However, these devices, I wouldn't say this is a typical install for us. These devices are mobile rated, IP rated devices that, typically they would get mounted directly, on the chassis or under the engine compartment in these machines. They are robust enough to survive in those environments. It just so happened on this application, we just, made that decision to give them a little extra protection by putting them in an enclosure. But yeah. So a little bit about the system architecture that we designed. We decided to use 2 different CAN networks, and then we isolated these CAN networks between the control system that we designed and developed, and then the engine CAN network. A large part of that was just, due to the amount of bus traffic that we knew we were going to have, on either one of these networks. I already kind of talked about the display and keypads and stuff, so I'll kind of glaze over that. But I did want to mention that that this sensor did have 2 CAN-based position sensors. There's 2 sensors that are located in the cylinders for the tensioning control for the main conveyor. And I have a slide to talk in more detail on that. And then there's also 2 sensors that are located in the steering axles that give us that feedback to tell us where the axles are doing. And I'll talk a little bit more about that and how we implemented the steering on this system. And then, of course, here's the two main controllers in the system. And these controllers are really used to control all the solenoids on the hydraulic valves and hydrostats, as well as bring in the feedback from the temperature sensors and pressure sensors that are located at various parts of the machine. So yeah, then on the engine network, like I mentioned, we decided to isolate this, and actually we're using our chassis controller as a gateway between these 2 networks, because there is still information that needs to pass between the 2 networks. For example, the throttle information is passed to our chassis controller, and then ultimately we're sending a torque speed control message to the engine to tell it what RPM it needs to run at. We're also sending it some other commands to do torque limiting and other things. In addition to that, we also pull some of the information from the engine as far as engine RPM and and different temperatures for oil in the cooling system. That's also being bridged across this gateway in that fashion. And then one thing to point out too is that on this particular system there is an option for a dedicated display from Cummins that primarily just focuses on the engine. So the customer chose that to put that in the system as well, is just kind of a dedicated display to mostly for the diagnostic capabilities, is that it already has all the diagnostic trouble codes programmed into it. So they use that for that purpose, and it kind of gave us made it a little bit easier that we didn't have to incorporate all of those things into our display. Not to say that we couldn't have done that, and it is something that we do for other customers. So moving on to the next slide here. Again, I just wanted to kind of emphasize the point that we consider CODESYS to be a full system development tool. So we use CODESYS for both the display programs, and we used it for the controller programs. I pulled just a few small samplings of just the screens that we developed for this particular machine, and it really, the main screen here is kind of shows the majority of the functions that the operator would see when the machine is being operated. As far as engine RPM, what's happening with their steering axles, what's happening with the conveyor system. They also have the ability to adjust how responsive the hydraulics are, and with different ramp rates. They can also monitor pressures and temperatures in the system, and then just various alerts and alarms that would pop up depending on how what's going on in the machine. And then in addition to that, again, this is just a small sampling of the screens, but just different screens that allow the customer to set up and configure various functions on that machine. So moving on, just so you fully understand all the different things that this machine is capable of doing, I wanted to just start with the cab function. So as you've seen in the pictures I showed earlier, is that this machine has the ability to lift the front and the rear up on the machine. And really the need for the lift in the front is driven, I don't know if you noticed in that picture, but in these large piles of corn, they have to provide ventilation. That ventilation is really what provides the airflow to that grain to prevent it from spoiling or from molding, turning it into a product that's not useful. So they need to be able to basically maneuver this thing around those vents. So they can pick the front of this machine up and maneuver it over there. The rear of the machine also needs to be able to obviously lift up so they can get to the level of the semi-trailer to fill it. But yeah, specifically talking about the cab control, since the conveyor geometry is changing depending on the operating conditions, the cab needed a certain level of maneuverability. So this cab actually runs up a track. So it allows them to bring the cab up to a high vantage point, so they can not only see what's happening with the grain pile, but they can also see what's happening with the semi-trailer. And then with that geometry change, they also needed a way to be able to rotate the cab, so they're not having to sit on a slope. So this entire cab will actually rotate, and allows the operator to rotate it to a flat or more desirable operating condition. And then along with that, this entire cab will actually rotate as well. So as they're filling a truck on either side of the machine, this entire cab can be rotated, so they don't have to strain their neck and see what's going on behind them. They can essentially just rotate the cab and have still a good vantage point of what's happening with the grain pile, and see what's happening with the semi-trailer. And then lastly here is, because there's no connection to that engine, is that they still wanted to have the operator, creature comforts. So there is a hydraulically powered HVAC system that we're controlling in the system. So moving on to the conveyor functions, I already kind of talked about the front and rear hoist, so we'll kind of glaze over that. The main conveyor, now, I have another slide to talk about this in more detail, but there's two large motors that we're controlling with a hydrostat for the main conveyor rotate. And then there's also a tensioning cylinder up here that controls the tensioning of the main chain. And then in addition to that, there's an auger rotate on each side to rotate these augers to bring that grain into the center of the machine. And then there's also a function that allows them to swing these augers up and lock them in place when they're in transport mode. And that's really, really to keep this machine under the minimum or maximum, I guess, length or width, to be able to to travel on the roadways. when it's being transported from job site to job site. And then, yeah, a little bit down here in the bottom about the spout controls. So this spout, it can be tilted up and down. It also has a telescopic function on it. And then lastly here, with the use of this hydraulic swivel, the spout can actually be turned in a full 360 degrees. So the operator doesn't need to worry about tangling up hoses or mechanical stops would prevent them from operating this. They can essentially just position it where they need it because of that full 360 degree travel. The other thing I wanted to mention, with all of the functions that you see on the system, they are fully proportional. So in our control system, we control the ramp rates and the max speeds, and all that is adjustable by the operator through some locked out screens that they can control the speeds of the conveyors and the work sections. Because as you can imagine, you wouldn't want to be 20 feet up in the air and swivel your cab and have it make a drastic movement. You'd want that to be a nice smooth ramped ramp movement. So that's something that we allow the operator, and ultimately we did a lot of that tuning up front with the customer to make sure that all the machine functions operate nice and smoothly. One other thing I wanted to mention is that the majority of the work sections on this machine utilize our Fastline valve products. And Fastline is a brand within Gem Technical, and it's really a quick ship valve program that we created several years ago. And it's made up of common products, common products of valves and bodies that can create common circuits. And the whole idea behind this program is that we stock these products. So if you have a circuit that you're going to prototype, or maybe you have an immediate machine need, and you need something quickly, we have all these products that will allow you to create common circuits in stock and available to ship within 24 hours. So keep that in mind if you are designing a hydraulic system and you need something quickly. That's something that we can potentially help you with. So a little bit on the hydraulic propel system. So the left joystick in the system is what we use to control the hydraulic propel. So the y-axis on this joystick is actually a friction-held joystick. So as you push this joystick forward, it actually holds its position and holds the speed, and same in the reverse direction. So that is kind of a standard way of operating a piece of equipment with a hydrostatic control. But one of the things that's a little bit unique to this system is that we worked with the customer to develop a crowd mode, and that crowd mode is a combination of kind of some electronic and hydraulic wizardry, where essentially what we do is that we limit the hydrostat. So what happens is that we can set a pressure for the ground drive system, and if that pressure is ever exceeded, basically it essentially de-strokes that pump. And really, by de-stroking that pump, we're reducing how hard that vehicle is, or the machine is driving into the corn pile, which reduces that load from the system. And that essentially allows the system to kind of run at its peak performance. It can push as hard as possible, or as hard as the operator will allow and possible, without stalling out the machine or slowing the machine down. So that's kind of a neat thing that we did on the hydrostatic, or with the hydrostatic control. In addition to that, on the ground drive system, it is a 4-wheel drive system, so we are electronically controlling a transfer case, and then we're also electronically controlling a service brake on this system. You can kind of see the hydrostat here. It's not a real great picture, but it's buried kind of in the the belly of the beast, I guess you'd say, and connecting into that transfer case. So on the steering side, we're using that same joystick, and we're actually using the x-axis of the joystick. And as mentioned earlier, there's position sensors in the axles, and we're controlling those cylinders in a closed loop position control. And the operator has the ability to set through the display essentially 4 different modes of operation for steering. The first 2 modes are front and rear steer mode, where essentially only one axle is allowed to steer. The other axle is locked in a center position. And then the other 2 modes of operation are crab steer and a 4-wheel steer. And that's really, if you think about a crab steer, is essentially all the wheels would travel in the same direction, allowing you to kind of operate, in a diagonal fashion if you needed that ability to maneuver the machine in that way. And then the 4-wheel steer mode the wheels would oppose each other. Essentially, in that mode, it gives you a really super sharp turning radius that allows you to maneuver the machine as needed. So yeah, so moving on to the main conveyor control. So as mentioned earlier, the main conveyor control is powered hydrostatically. There's actually 2 drive motors in this system. And just to kind of put this into perspective, these motors are, I think, they're the closest thing that I can relate them to would be like a 5-gallon bucket. So they're extremely large motors, and they're driving this extremely large conveyor. And actually, to give you an idea of how big the chains are on each side of this conveyor, is that they're about 6-inch lengths. That's essentially driving this large conveyor. So these 2 motors, they are directly coupled together. But there is still a need to keep them in alignment to prevent one motor from pulling harder than the other, or from the conveyor system from getting out of whack. So we implemented a closed loop position control using the position sensors. So we use that to position these at the same location on each side, and then we also use pressure sensors to give it some additional overload protection. So that overload protection, essentially, either it'll alert the operator that something is going on, or potentially even shut down the system if that pressure rises above an acceptable level. So kind of a neat thing that we implemented for that tension and control as part of the system. And then I think lastly here is on the hydraulic cooling system. And I wanted to point out one of the neat things that Global does on these systems that I think is kind of neat is that they actually isolate their subsystems. And what I mean by that is each subsystem in the system, it has its own individual cooler. And really what that does for them is that if if they ever have a failure, like a motor or something else that fails in their system, and you have contaminants that enter into the hydraulic system, rather than those contaminants going into the entire hydraulic system, potentially damaging other components, they've isolated those into individual components. So really, if there is a failure that occurs, it's really isolated to that system. So they can fix the component in that system, flush out the system, and get their machine up and running quickly. So that's kind of a neat thing, just how they design their cooler system. As far as what we're doing with it, so we are controlling each of these coolers individually. We're staging them to, because these are electric fans that we're controlling. So we have some, staging control that we do to make sure that they're not all coming on at the same time and exceeding the max amp draw that the system's capable of producing. We're also measuring the temperature in the coolers, and also monitoring the hydraulic reservoir fluid levels. And then in addition to that, on the main cooling system for the engine, this engine actually has a fan controller ECU, and that fan ECU allows us to send it commands through Jane 1839 to put the fans into a reverse flow direction. And the need for that is, if you're familiar with the agricultural equipment, you know that there's a lot of dust, there's a lot of debris in the area, and these coolers tend to get plugged up. So what we do is we implemented a reversing sequence that essentially we can send commands to the engine to tell it to reverse the flow, to blow some of that debris out of that cooler. So hopefully it'll allow that cooler to operate more efficiently, and reduce the need for somebody to manually come and clean out that cooler. So that was kind of another kind of neat thing that we did on this particular system. So, and then that concludes my presentation. I wanted to show you just one last slide of this thing in action, of picking up a corn pile.